Malcolm Training Tutorials, Analysis, Hypothesis-Driven Threat Hunting. This is an overview of hypothesis-driven threat hunting for industrial control systems, ICS, and operational technology, OT, environments. Malcolm Training Topics. In this video, you will learn 1. A basic overview of threat hunting. 2. Review an in-depth example scenario. Step 1. Overview. A basic overview of threat hunting. To begin, network profiling focuses on understanding the points of ingress and egress within a network. This involves analyzing how external connectivity enters the network and how it exits. This video will concentrate on network profiling from information technology, IT, and operational technology, OT perspectives. To infiltrate an OT environment, it is crucial to identify a path from the attacker's location to the target environment. For instance, the Stuxnet incident involved a USB device being connected to an OT device, allowing sensitive application changes to be made on the devices operating the infrastructure, which impacted the ongoing process. Engineers often need to update programmable logic controllers, PLCs, or programming of other critical devices. These updates can be exploited if they involve external channels. For example, an engineer may access a jump box within a demilitarized zone, DMZ, to move through the DMZ and into the OT environment where they would have the ability to cause adverse effects. Poor IT practices, such as not updating operating systems and edge point devices, can allow exploits to move freely between different environments, exacerbated by firewall issues and update management. Transient devices, such as laptops used for both emails and field updates, can move malicious actors as well as software between environments. This movement, often cost-saving measures, can introduce vulnerabilities if the device is not properly secured. Information can flow from OT environments to IT environments, particularly through log propagation. For example, a historian device in an OT DMZ might gather logs from field PLCs through a firewall. If this historian is not securely isolated, it could serve as a pivot point for further infiltration into the OT environment. Proper network profiling requires a detailed understanding of how connectivity enters and exits the network, the identification of side channels, and the management of transient devices. By addressing these areas, vulnerabilities can be mitigated, and the security of both IT and OT environments can be enhanced. In hypothesis development, it is important to recognize that attackers prefer a low-effort target. They are more likely to target configuration issues, inappropriate connections, or vulnerabilities arising from IT migration, as these situations create more exploitable environments. Typically, the devices that pose the highest risk are not the ones attackers need to exploit through new techniques to compromise. Therefore, the focus should be shifted to environments that are more likely to be targeted, particularly those of an IT nature that can interact with OT devices. These environments generally require no novel approaches for attackers to achieve their objective. Networks and identification of OT-specific communications play a crucial role in investigations. For instance, determining what is visible within protocol communications and profiling behavior are key steps. If OT protocols are identified within an IT network, this is likely to indicate a configuration issue. Monitoring an IT-focused network that shows OT protocols such as Modbus or OPC-UA suggests an incorrect setup or a test environment that is not properly segmented. These indicators can lead analysts to find potential configuration issues or malicious activity. Topology validation is a significant aspect of IT asset control. This involves comparing expected network and segmentation layout with the actual observed environment. Discrepancies between the expected and actual network topology can highlight vulnerabilities and misconfigurations. Host artifacts are often collected manually unless the OT environment has a log aggregation system in place. Key artifacts include Windows event logs, human-machine interface, HMI, activity, and engineering workstation, EWS, activity, and records of remote connectivity. These logs can be correlated with network traffic to identify anomalous behavior or integration issues. It is essential to monitor processes on critical assets. This includes examining what is executed on HMIs, engineering workstations, and historians. Look for potentially unwanted programs, PUPs, verify regular updates, and ensure updates are validated. These activities fall under the broader category of allow listing, though practical implementation can be challenging. By focusing on these areas, you can better detect anomalous behavior or integration issues. When analyzing network traffic, it can be challenging to determine the most interesting components. Analysts often do not want to examine all network traffic, so they focus on identifying key observables. For example, when analyzing Modbus traffic, noticing this within an IT network might suggest incorrect network segmentation. This observation can form the basis of a hypothesis. In this example, you may hypothesize that a network device in the IT environment is communicating with an OT device. Once you have established an observation and formed a hypothesis about the device, the next step is to validate it. By focusing on key observables and systematically validating hypotheses, you can effectively analyze network traffic and identify potential issues.
Step 2. Scenario. An in-depth example scenario. In this scenario, there is a company called Rusboro Oil that specializes in oil transmission for electricity generation. As an incident responder, you are called in because engineers have observed valves within the OT environment opening and closing randomly, with no known changes made by the operators. Rusboro Oil is a small company with basic network and host logs and no historical instrumentation data. Your goal as the incident responder is to gather information from the outset and determine what is happening. I would like to gather some information about your network. Do you have a few minutes to answer a few questions?
I do. What would you like to know?
How do you connect to your IT environment from external locations?
The company uses TeamViewer, which is common but not ideal due to potential security risks.
How are updates handled?
The company relies on a system integrator for updates and schematics. If you would like, we can examine the network topology.
That would be great, thanks.
The internet connection goes through a firewall to the primary modem, which communicates with a router in the IT department, supporting the HR, IT, and engineering departments through a switch. A second firewall connects to a switch with two jump boxes for engineers to use when they need to make modifications to OT equipment. Historians log field activities and communicate through the firewall. The next firewall to the OT connects to an HMI, an engineering workstation, a PLC in the field, and multiple RTUs.
The network is stated to be segmented, but there are potential methods for an attacker to move laterally through the environment. The jump boxes in the OT-DNZ could be leveraged by an attacker to access OT-DNZ components. Historians are one class of devices here that are frequently overlooked and can be a potential weak point. We should form hypotheses based on these observations. In this scenario, engagement kits with sensors are connected to span locations in both IT and OT. Sensor placement is critical. Place one sensor on the OT switch to collect data from OT assets. This helps trace unusual activity, but must be correlated with IT data to determine the origin of the access. A second sensor should be placed to monitor what accounts are accessing which assets in IT and OT. If you observe OT protocols like DNP3 in the IT network, this indicates misconfiguration or inappropriate testing. Investigate the source, such as an engineering workstation that may be transient. Use tools like Malcolm's parsers to analyze protocol data. For instance, Modbus parsers can show if commands like CPU resets are being sent unexpectedly. Traffic from hosts within the network can be focused on if an HMI is sending out CPU resets. Focus on that HMI. Check logs for jump boxes connected to the HMI. For example, if logs show RDP connections from an engineering workstation to a jump box shortly before the issue, investigate further. Trace the attack path from TeamViewer connections to the engineer's workstation, to the jump box, and then to the EWS within the OT environment, ultimately reaching the PLC to cause the CPU reset. This path shows how attackers move through the jump box within the OT DMZ and access the HMI to issue commands to change the state of multiple valves. By following these steps, you can systematically respond to unusual activity in an OT environment, gather critical information, validate hypotheses, and identify the root cause of the incident. After looking at your network segmentation, we came up with an initial hypothesis. Then we performed network and host analysis. Based on that information, we refined our hypothesis. Our refined hypothesis is that a remote actor somehow connected to the environment. To do this, they would have had to collect legitimate credentials from TeamViewer. They used those credentials to connect to an engineer's IT machine. Then they pivoted to the jump box within the OTDNZ, accessed the HNI through the jump box, and issued commands from the HNI to change the state of multiple valves.
Thank you for the hypothesis-driven hunt.
When doing this yourself, there are a few things to keep in mind. First, always consider the easiest path first. If there is something open to the open internet, it is going to be trivial for someone to get in that direction. There is no reason to jump to the highest difficulty at the start of the journey. Another thing to build a hypothesis is asking yourself who can touch your system. Working backwards in this way will allow you to build different hypotheses. Lastly, trust customers but verify the environments.
This concludes hypothesis-driven hunting. Thank you for watching. Check out the description section for links to the Malcolm GitHub site, a Malcolm discussion forum, and more.